And we'll be going on to our next speaker. When it comes to decoding byte streams for processing, our next speaker has a trick for that he would like to share with you. Duplicating and optimization strategy you can find in Protobuf or in other zero-copy Rust libraries. He was able to generalize it into his own optics library, EO. You can already see him. I hope you can hear us. Rodolfo, can you hear us?
Can indeed.
Yes, you can. So Rodolfo will teach us the trick how to avoid serialization and deserialization of your data. And with 25 years of experience in coding and coding in Scala from 2008, yes, he brings a really big chunk of knowledge to our conference table. He's a valuable contributor to our industry. Just one of them mentioning, because we don't have too much time, like creating the first Megan plugin for seamless interaction with Google App Engine. So, Rodolfo, over to you, Senior Software Architect, Quality and Excellence at Philips.
Thanks. That's I'm bashful. You've made me shy with that introduction. So pleasure to be here with everybody. Super nice that this talk is immediately after an optimization route for JSON serialization, because this is exactly another path that you can try, right? So the whole thing that we do every day is have this, if you're running a web server, if you're processing any data from the network or from files, is that you're just reading binary data, right? You're reading a disk format that isn't the native arrangements in your language, right? In this case, Java case classes, etc. And you have to decode them. Maybe you have to decode a bigger class and process all the bytes of the byte stream. And then you go, you make your changes, you make your transformations, you have a new person to, and then you write the whole thing back to JSON. That's exactly what we were seeing before of how do you optimize this round trip information, right? And maybe you could do it a little bit better, right? Maybe you can actually look at seek into the JSON format or the binary file format and only look at the bit of data that you want to change, right? Maybe you only need to look at the address inside the person and change that into a new address and then write that specifically, right? But this round trip effort, what if, like, why don't we just do that? What if we can fully avoid the round trip transformations into our class files, into our business logic, into our easier way of understanding things, and just write the byte data? The obvious reason why we don't do that is because it's extremely cumbersome. You do not want to have to manipulate bits directly. It's error prone. It is impossible to discuss with stakeholders or to establish anything meaningful with regards to requirements or properties, etc. But maybe there is a way that you can sidestep the problem and not have to pick between this binary, impossible to read, but extremely fast alternative where you do know serialization, or this one where you have to do the round trips, right? Here comes optics. I do not know how many of you are familiar with optics. Unfortunately, I can't see the screen, so I can't ask for a raise of hands. But optics actually encode this reality. So maybe you've seen lenses before, maybe you've used, what is the name of this Java library by Julien Truffaut? It's a Monocle. Maybe you've used Monocle before, and you already know that there is a source type, right? S, that is somehow related to T, right? In this case, one is the in-memory representation of a person, and in the other case, the T, it is the binary or JSON representation of a person. And then these two are homologous to each other, but they have there's another pair of types that are connected to S and T. So if it's a lens, that means that an address, so A is a part of S, right? You can peek into a person and see their address. And the same way, this bit of JSON is a part of the larger bit that is always located here, right? And this bit of JSON is the analog of the address in its JSON representation. So this is the extended version. This is the polymorphic version of a lens, of an optic, right? Usually you might just see S and A. There's prisms, there's traversals, there's a lot of optics. We're going to focus just on this one. Maybe no questions in the online chat. But let's go and revisit again in the specific case of a JSON, right? So you have S, right? Again, the optic is the source, and then it has this source, right? The person type has a JSON representation, and then there's a part or a reference, right? Another class A, and this is the address and its own JSON representation, right? And this relationship, right, this whole diagram is actually captured very nicely within an optic. So maybe we can track changes between S and A in such a way that we only need to we write the code this way, we write our business logic within this realm, and we get the compiler or our system to actually make the changes in this realm entirely, right? So we're going to use a different encoding of optics to do this. We're going to use the existential encoding, right? There is the way this is understood or interpreted is that you have this additional existential type X, this hidden mysterious type within the optic that says to go from S to A, there's a hidden extra bit, right? There's the complement or the companion object. If you think of a case class, right, and a person has an address and maybe a name, then this X bit is the name, right? And then when you combine the name and the address again, you can go back to and see the person, right? So this is how you encode optics existentially. You have a hidden type that is what is missing, what the complement is, and each optic has its own complement. So for prisms, it is an either, right? So it is an optional type. And for so F becomes an either. Anyways, in the case of lenses, it is just this F becomes a tuple, and this is the other part of the what is missing to get S. With this encoding, maybe we can be smart and figure out what it is that we need to prove, right? Or what it is that we need to get the operation to work, to compile. So as a exercise in can I actually make this code compile, let's say I have an optic, right? And this is the general case again, right? So I have an optic that connects all these types. And I want to be able to write this method that if you give me a JSON, the JSON bit from inside, then I can give you back a function that goes and mutates or updates a bigger chunk, the bigger representation of person, and gives me the new updated version. So I'm going to go ahead and place B into T. And it just so happens all I need is this bit of proof, this evidence of decomposition. So if I can share with you that I can split out T as well into some complement and this JSON bit, then I can run it, right? This is this from in the definition that has the complement and B go back to T. Then if I do add the missing bit, right, and I go, and well, yeah, sure, if you give me from T to a complement and B, then that's all I need to do, right? Here is the placement, right? Now I can place JSON into JSON in the rest of the machinery. Maybe I want to not have, or I don't have the JSON right away. So I am going to, in fact, decode only the address, rewrite it, change it in my business logic, and encode that to JSON, and then push this here. So the evidence I need to pass is slightly different. I don't need to pass a complement with B, I can pass it a complement with A. And you see that transform is also easily implementable, right? It's like, well, now I have two versions. This is annoying. Which of the two do I use? It just so happens that the fact that I was using A and B is just accidental to my use case. And if I add an extra type to this system, then I do not care what the actual additional bit is. I'm only worried about the complement because when I transform, I have a method that goes from B to D. So I'm always going to get what from needs. And that means I can change and bring anything in and go back and write directly to my JSON stream, whatever it is that I need. Now you're gonna find this interesting. You can take in and stitch together different streams and avoid decoding almost always, right? I'm gonna go back to here and give you a little peek of how you can do this. And this is general for any optic. And in the special case of JSON, right, and it turns that this complement can be, instead of, for the case of case classes, in the case of JSON, the complement can just be the zipper, right? If we were talking about Circe before, you have an H cursor. You have a cursor that has the history of where it's going to move. It's going to move like nesting here, look in this, find the array, find the first value, and it has a cursor here, and it's going to be able to replay the actions to transform and get you back. And you'll see that in the composition of the optics, that the intermediate step is still the H cursor, and you see that you're able to replay the mutations, right, of the operations of one JSON cursor, right, the history, onto the parent cursor. And now you get a cursor that is now navigated further nesting inside automatically for you. That is it. You can check out the repository. It is in a branch. The changes here are in a branch. And I also shared this slide in the presentation, in the GitHub repo, in this branch. You'll be able to see a little bit of the actual code of how it works that I am now sharing. And you can see here the idea of just being able to pass through, right? Transform the full type of the person, right? Be it Bob, right? It just changing his mobile address and getting the JSON straight back. Questions, comments? What do you guys think of this idea?
Any questions? We still got a minute or two. Or thoughts, as Rodolfo said, or maybe you need to digest it a bit. I think, Rodolfo, they need to digest it. So probably yes, or I see any hand? No, so probably they will reach you out. You got the details. If you have any questions, you want to know something more, so you can contact Rodolfo. Is that okay?
Yes, perfect. You guys can find me on LinkedIn, on Twitter, on GitHub as well. It's a very nice idea where you can just avoid doing the work altogether, and you keep the optic is just proof that and tracks the changes needed, right? It tracks and keeps a cursor for you on the other end, on the mirror side of your structures. So it's quite an interesting and powerful idea. We did it with JSON, but you could do it with any other data type.
Okay, perfect. I guess we got it. So thank you very much, Rodolfo, for your time, and hope to see you next time in present. Big round of applause.